Let's do this question. An integer is chosen at random from numbers 1 to 100. What is the probability that it is a multiple of 2 or 5 or 7? Pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Let's start with drawing this in a diagram so that we can easily visualize this. So to understand more of this, check any section where Venn diagrams are explained. Alright, let's move on. I can draw it in this manner where I have three circles. One is for the multiples of 2, the other one is for multiples of 5, and the other one is for multiples of 7. Now let this rectangle over here represent the universe of events that can occur, which is any number from 1 to 100 can be picked out, right? So there are 100 possibilities. Now the possibilities where we get a multiple of 2 or 5 or 7 is this shaded region, right? And the probability that we have to find is favorable events divided by total events, that's equal to the shaded region divided by 100. All right, let's quickly understand why this is so. All the multiples of 2 will come over here, right? For example, 2, 4, etc. All the multiples of 7 will be over here. For example, 7, 14 would be a multiple of 2 and 7, so it will come over here. 21 will be over here, 28 would be over here, etc. And the multiples of 5 will be over here, 5 is over here, 10 is over here, 15 is over here, 20 is over here, etc. So all the numbers which are either multiples of 2 or 5 or 7 will come in this shaded region. So we just need to find how many numbers are there in this shaded region. And we know the total possible outcomes are 100, right? Which is 1, 2, 3, etc. up to 100. So any of these 100 possibilities can occur. So the total possibilities are 100. Alright, let's move ahead and try to find how many numbers are there in this shaded region. Let's start with the multiples of 2. How many multiples of 2 are there up to 100? We start with 2 into 1, 2 into 2, etc. up to 2 into 50, right? Because 2 into 50 is equal to 100. Now we can see that we have 1 over here, 2 over here, and this goes on till 50. So therefore, up to 100 we have 50 multiples of 2. This 50 could have also been obtained by doing 100 divided by 2. Alright, let's move on to the multiples of 5. How many multiples of 5 are there up to 100? We have 5 into 1, 5 into 2, up to 5 into 20, because 5 into 20 is equal to 100, right? Now over here we have 1, we have 2 over here, and this goes on till 20. Therefore we have 20 multiples of 5 up to 100. Now this 20 over here could also have been obtained as 100 divided by 5. Alright, let's move on to multiples of 7. So how many multiples of 7 are there? That's 100 by 7, which is equal to 14 if you leave out the remainder, right? And we can also do it as 7 into 1, 7 into 2, etc. up to 7 into 14, right? Because 7 into 14 gives you 98. Now that's the same 14 that we've got over here. So there are 14 multiples of 7 up to 100. Alright, let's keep this aside. We have seen that we have 50 multiples of 2, 20 multiples of 5, and 14 multiples of 7. So can we say that the favorable cases are 50 plus 20 plus 14? No, we cannot say that, right? Why is that so? Because when we say that there are 50 multiples of 2 and there are 20 multiples of 5, we will be double counting the multiples or the integers which are both a multiple of 2 and 5, right? For example, over here you can see that this 50 represents the numbers which are there in this circle over here. Similarly, this 20 represents the numbers which will be filled in this circle over here, right? And you can see that there is an overlap between these two, right? So if we just do 50 plus 20 plus 14, we will be getting a number which is greater than the number of numbers which are there in this shaded region. Alright, so let's find out how to go ahead from this point onwards. Let's start finding the common numbers. What are the multiples of 2 and 5? that would be the multiples of 10, right? And in 100 you have 10 multiples of 10, that's 10, 10 into 2, 10 into 3, up to 10 into 10, right? So there are 10 multiples which are multiples of 2 and 5. What about 2 and 7? How many multiples are there? You can see that there are 7 multiples which are multiples of 2 and 7, because when you want to find out multiples of 2 and 7, you just need to find out multiples of 14. So this one over here is 14 into 1, 14 into 2, which is 28, 14 into 3, etc. up to 14 into 7. 14 into 7 is 98. So 1, 2 up to 7. So we have 7 multiples which are multiples of 14 up to 100. Alright. Now what about multiples of 7 and 5, right? Let's find that out next. Multiples of 7 and 5 can be obtained by finding multiples of 35, and 100 by 35 is equal to 2. So there is just 35 into 1 and 35 into 2, because 35 into 2 is 70, 35 into 3 will be more than 100. So there are two multiples of 7 and 5 in the first 100 numbers, that's from 1 to 100. Alright, what about multiples of 2, 5 and 7, which is this region over here? We will have one multiple or one number which is a multiple of 2, 5 and 7, right? Because we just need to find multiples of 70. So you have just 70. The next one would be 140, which is greater than 100. So we have only one number which is a multiple of 2, 5 and 7. Alright, let's move on. Now to find this shaded region, what is it that we have to do? We have to add 50, 20 and 14, and from that we need to subtract 10, 7 and 2, and we need to add 1. Let's try to understand why that is so. When we add 50, 20 and 14, what are the areas that get double counted? Let me mark these 1, 2, 3, 4 areas so that we can understand this better. Let this area over here be 2A. Let this one be 2B. Let this one be 2C, and let this area over here be 3. Alright, now when we add 50 plus 20 plus 14, this area and this area gets added only one time, right? But 2A will get added when you add 50 and when you add 20 for multiples of 5, right? Therefore 2A is added 2 times. Similarly, you will see that 2B is added when you add the multiples of 2, which is 50, and when you add the multiples of 7, which is 14. Therefore 2B, which is this area over here, is also added 2 times. Similarly, you can see that 2C is also added 2 times. Alright, and what about 3? 3 is part of multiples of 2, multiples of 5 and multiples of 7. Therefore 3 gets added 3 times. Alright, now when we subtract 10, 7 and 2, what is it that we are subtracting? 10 is the multiples of 2 and 5, right? That would be this area over here, which is 2A plus 3, right? So we are subtracting 2A and we are subtracting 3. Similarly, when we subtract 7, which is the multiples of 2 and 7, we subtract 2B and 3, because this is the area where we get 7 over here, 2B plus 3. So that's getting subtracted. So let me write that over here, minus 2B minus 3, and when we subtract 2, we are subtracting 2C and 3. So minus 2C minus 3. We can see that 3 is getting subtracted 3 times, 1, 2, 3, right? So that and this part over here gets cancelled out, and 2A, 2B and 2C is getting subtracted 1 time. So this 2 over here will get cancelled out. 2 minus 1 is 1, right? So we are left with these 3 areas and 2A, 2B and 2C, right? So we can see that this area so far is not accounted. That's why we need to add 3 to this. So when we do this 50 plus 20 plus 14 minus 10 minus 7 minus 2 plus 1, that gives us 66 as the answer, and that is the number of integers from 1 to 100 which will be there in this shaded region. Now we know that probability is favorable events by total events. We have found that favorable events are 66. That is, there are 66 numbers from 1 to 100 which are either a multiple of 2 or 5 or 7. So the probability is equal to 66 divided by 100, and 100 is the total number of outcomes possible, which is 1, 2, 3, etc. up to 100.